questions are generally asked. Connectionless data transfer, what is this? And connection oriented data transfer. Connection oriented. Can you give an example? Anybody? What is connectionless data and where actually it happens, and when is connection oriented data transfer? Can anybody answer it? Can anybody answer it? Where connectionless data is there, or where connection oriented data is here? Can anybody suggest? Anybody can? Yes or no? Can anybody suggest what is connectionless data transfer? Can anybody guess? You simply say yes or no. Anyone is responding? Can you mention anybody? Sahil or yeah. What's about done? Anybody? Those who are listening? No, no one is listening. Can anybody suggest what is connectionless data transfer and what is connection oriented data transfer? No one. Okay. You see, in connectionless data transfer, that times you see it will be in unplanned fashion, like say unplanned fashion. That is actually like say datagrams. You have seen the datagram. There is no specific route. Data can travels any of the routes available in the networks. And connection-oriented data transfer is a virtual circuit approach. First, a logical connection is established. So that is actually connection-oriented data transfer. But you see, and in this case, lengthy messages are most, when you want to transfer very long messages, I mean lengthy exchange of data, that times connection-oriented data are preferable. But when you consider this connection-oriented data transfer, that times three phases are there. There are the three phases: connection establishment, data transfer, and connection terminations. Right? And you see, this is the three pages. These are the three pages. First, the protocol entity will send the connection request, and next, if it is ready to accept, then connection acceptance will be there, and next, after acceptance, the data will be transferred and acknowledgement will be there. And any of the stations can terminate the connections by sending the request, connection request, termination request, and it will be accepted by the, if it agrees, then it will be accepted by the other entity. So this is the connection oriented data transfer. Now next is you see order delivery. Another function is here. Whatever is here, you see when the two entities are connected through a network, the risk will be some risk will be there that the PDUs may be reached in out of order, right? Because they may travel different paths through the network, right? In connection-oriented protocol, of course, it is required that PDUs order must be maintained, and if each PDU is given unique numbers, then receiver may easily reorder the PDUs on the basis of the sequence number. So if sequence number is if sequence number is provided, then the PDUs, the packets or PDUs, etc., they may be accepted sequentially in order, right? So that is the order delivery. Next, flow control. These things we have seen. High flow control. That is also another functions provided by the protocols, and we have seen this when protocol flow control. This is required whenever the sending transmitting rate is higher than the receiving rate of the destinations, right? Overflow will be there, right? So buffer will be filled, etc. Those things. So it needs to flow controls, and we have seen this conventional, the most simplest protocol. It is stop and flow control. By withholding this acknowledgement, the flow control can be realized. Flow control can be implemented. Also, there can be credit-based sliding window flow control is there. That can be also credit-based. Advanced techniques are there, and based on sliding window flow controls. So, there are the techniques: sliding window flow control, stop and flow control. These techniques are there, right? So this is the under flow control. It is needed at the application as well as the network layers. Next is the error controls. Error control also this is provided by the protocol, and we have seen this. There are different error control protocols are there. Here actually two things are there. Two functions are there: error detections and retransmissions. Error detection and retransmissions. You see, this is error detections and retransmissions, right? If error if error is detected, the packet will be discarded, and also if no acknowledgement is there, then it will be retransmitted. So there are several protocols are there. We have seen this: go back in ARQ, stop and wait ARQ, selective reject ARQ. Those things, those protocols are there. Next, you see addressings. Another function is provided by the protocol, that is addressing. Addressing in communication architecture is a very complex ones, and different issues are there. There are different issues: addressing levels, addressing scope, connection identifiers, addressing mode. In addressing levels, a particular entity is it is something that refers in architecture, that refers level in architectures where entity is named. Right. Entity is named, and a unique address is provided to each end systems. Maybe computer, maybe router, maybe server. So and a unique address is provided with each end systems. Right. That is addressing levels, and this is a network level address. And in TCP, TCP/IP, it is called the IP address. It is the IP address. You have seen this computer when you use the internet, IP address is required. So that is the TCP/IP IP address. And OSI, it is called Network Service Access Point, NSAP in OSI. This is practical. I told you this is actually used in internet. And you see, but you see, this is a global address. Sometimes and sometimes you need to this global address enables an internet to route data from any system to any network to any other systems. But sometimes in a system there can be port ones like these things. Port 1 is system A, port 1 is system B, like these things. So that issue it is solved by the addressing scope, and it is relevant for network level addresses. You see addressing scope here. You see, so in this case there can be port 1 in system A, or there can be port 1 system B, like these things. So the full designations of these two ports can be expressed as A.1, A.1 and B.1, like these things, right? Which are unique designations. So this is actually the addressing scope, right? Addressing level is the global ones, and it is the local ones. Next, you see connection identifiers. You see, sometimes we consider. I mean, if you consider the this is connection identifier is important in case of connection-oriented data. I told you the two types of connections, two types of mechanisms are there for the data can be transferred and connected oriented data transfer, and there is connection-less data transfer, that is datagrams. So, and this connection-less data transfer actually a global identifier used in case of connection-less, say, for datagrams. That is for global identifiers. But for connection-oriented data transfer, it is required for connection identifier for data transfer. Generally, a number is provided in this case. Connection identifier, a number is provided. Number is provided in connection-oriented data transfers, right? And this, if you use this type of numberings, then it will have several advantages. you will get that will be reduced overhead, right? Connection identifier is shorter than the global identifiers. That's why there will be reductions in the overhead. And you see routings. Routing also, in setting of connections, a fixed route may be defined for these connection identifier, using these connection identifiers. Also, it helps multiplexings. Entity may wish to enjoy more than one connection simultaneously, right? So that is the multiplexings. If several connections may be linked together, right? And also it can provide this through the connection identifiers. We can have the state informations. If a connection is established, the end systems can maintain the state informations related that will be related to the connections. So these are the advantages of the connection identifiers. So another thing is there in addressing mode. Addressing mode in this case, an address generally refers can be referred to a single systems. If it is single system, then it is called unicast address. Single systems. And say example, send to one machine or persons, unicast address. But sometimes address may refer to multiple to all entities within a domain. All within that is a broadcast. Right, there's a broadcast address. So address can be broadcast address, can be unicast address. Also, that can be the address can be a subset, of the entities in a domains. That is the multicast address. So address can be multicast address, can be broadcast address, can be unicast address. Right, unicast address. A group of persons, say in a class, certain group as a whole class, then it is broadcast. In a group of persons within a class, then it is multicast. If a single person, then it is unicast. So these are the addressing modes. Addressing mode. Next, multiplexings. I just mentioned earlier also, multiple data links connections can be there in a single end systems. So these connections are multiplexed over the same physical interface between the end systems and the network. Right. So this type of some protocols are used for this purpose also, for multiplexings, right? Also, protocol some provide extra services, can provide extra services like the priority, quality of service, security, etc. So these are the functions of the protocol. So once you see what are the functions of the protocols, mainly, I mean the key functions of the protocol. There are other functions are there. The main functions, encapsulations that we have seen nothing but the addition of control information to data. Segmentation breaks the PDUs into smaller PDUs for the suitable networks. For that will be suitable, that will fit a particular network. Connection controls. I have seen these can be connections, can be connectionless, connection data transfer. So different phases are there. So that is connection controls. Generally, this service is provided for connection-oriented data transfer. Order delivery, some numbers, unique number is provided so that PDUs can be collected in order in the destinations. Flow controls, we have seen this. The flow control protocols we have seen in details. To reduce slow down the sender transmission rate to avoid the buffer flow like these things in the destinations. Error controls to I mean it is used for these to overcome the loss of packets or loss of the informations, I mean message or damaged frames or the lost frames, to overcome these things. Addressing, just to have seen different addressing schemes are there. Multiplexings and subsequent the transmission services. So these are the protocols. Now let us focus on the any questions, anybody from your side, from these protocol architectures? Anybody from any one of you? Any questions? Now I'll switch over to another topic, that is local area networks. Anybody, if you have any questions, quickly can you unmute and say yes or no? Anyone? Anyone of you? No one. Just a minute. I'm showing some other. No one is responding. Susmita, are you listening? Sasat, Ankush, Vishal, Nishchoy. Can you unmute anyone? Ankush, Susmita, Nishchoy. No one is responding. Vivek. No one is responding. Vishal Kisko. Any questions from your side? No question.
No, sir.
Okay. The other ones. LAN. Now we'll see the LAN protocol architectures. Vishal, slide is visible. This slide. Just a minute.
Yes, sir.
Yes, sir. The slide.
Okay. This is the LAN, local area network. Right. Why this local area network is required? You see, because this slide local area network is visible, na? Okay. You see. Yes, okay. Now, if you see anywhere in academic or the scientific engineering applications, scientific applications, or any business organization, you have seen several systems are there, several working groups are there. They want to share their resources. I mean, several clients, several servers are there, right? And they want to share the resources. Right. So there'll be absolute requirement to interconnect the different systems. Maybe in the office, maybe in the buildings, in the factory, or any other centers. So basically, you see, it needs to share an exchange of data among the systems, and also it needs to share expensive resources. So that's why you need some networkings. I mean, need to share. There is a need to share data. That is the need for these interconnections, right? I mean, this is, you can say, communication network. This communication network. So there is a need of networking. This networking can be three types. Can be LAN, MAN, WAN. Just a minute. LAN can be MAN, and can be WAN. Local area network, metropolitan area network, wide area networks. So there are three types of communication networks are there, right? If you see the wide area network, that is not there anyway. If wide area network is how it will classify these three types of networks? Wide area, based on the geographical. There are different ways of distinguishing the communication networks or classifying the networks. One way is the which technology is used. Another, I mean, in terms of topology, in terms of transmission mediums. Also, the communication network can be classified in terms on the basis of the geographical scope, right? I mean, depending upon the area. So, if you see the WAN, it covers a large geographical area, right? It may consist of a number of interconnected switching nodes, right? And a transmission from any device, generally it is routed through the different internal nodes to a specified destination device, right? So examples of, say, it can be ISDN, integrated service digital network, like these things, right? Of course, here the rate is T1 rate is used. Optical fibers nowadays it is used in WANs, right? I mean, say several in one continent to another continent, so they can be connected through WANs, or in a country, different cities can be interconnected through WANs, right? And nowadays optical fiber for huge bandwidth optical fiber. That's why optical fiber can also being used in WANs. Now, this the LAN. The LAN is another network, commercial network is here. There is LAN, local area network, that is limited to a buildings, that is limited to small buildings or clusters of buildings like these things. So that is the difference between WAN and LANs. WAN covers a large geographical area, but when LAN it is limited to a small buildings, right? Or maybe cluster of buildings, or maybe within any buildings within different offices. You have seen this in a laboratory also. LAN can be created. So and another thing is this, another criteria for LAN is this: it is generally owned by the same organizations that actually owns the attached devices. But for WAN, a large section of network assets are not generally owned by the organizations, right? And network management responsibility also for a LAN, it falls only on the user, right? So these are the differences between LAN and WAN, and also internal rate of LAN generally it is much greater than that of WAN. And next is the MAN, metropolitan area network. It is in between this LAN and WAN. Here actually the it covers greater distances, higher rates than LAN, right? And it is intended to provide the capacity at lower cost and greater security, right? And delay in this case, in case of MAN, metropolitan area network, the delay may be slightly higher than that of the LAN. And a MAN may be owned or operated by single organizations, but many individuals can use that, can be incorporated. Many organizations can be incorporated in a MAN, right? And these MANs generally provide means for networking of local networks. So anyway, it is in between. It is the middle ground between the LAN and WAN. This metropolitan area networks, right? And if you see in the applications, so let us focus on the LANs. And if you see, because we are going to discuss the LAN protocol architecture, so that's why we are focusing now LAN. And it's almost similar applications are there for MAN also. So LAN generally applied in personal computer LANs, computer local networks that supports personal computers, right? This is one. It can be applied in backend networks, and storage area networks. Here it provides interconnections among the large systems, mainframe computers, right? And the characteristics of this network will be a high data rate, high speed interface, distributed access, limited distance, limited number of devices. They are the characteristics of the backend networks, right? Right. And storage area networks, there are two types of applications. One is backend networks, another is storage area networks. Here you see in storage area networks, little difference is here. Here I'm just showing in the diagrams. Here you see, this is the backend networks. Here you see the mainframe computers connected directly, right? Directly, say storage devices. If any client in the storage device here wants to access the resource at another storage device, then it has to go through the server connected to these mainframes, right? But in this storage area network, you see, हाँ तब হ্যাঁ তো একটু আমি ক্লাসে আছি এখন তো ক্লাস চলবে আমি ওই তোমাকে 12টা 15 নাগাদ ডাকবো অসুবিধা আছে 12টার পরে হ্যাঁ হ্যাঁ সেকেন্ড হাফে আমি এখন লাগাতার ক্লাস নিচ্ছি এক্সট্রা ক্লাস নিচ্ছি একদিন হ্যাঁ ঠিক আছে and in case of storage area networks you see there is also LAN is implemented here but the difference is this here you see this here storage devices are connected through high speed data bus easier you see this is the high speed data bus is here here there is no need say if a client wants to access the resources at other storage devices one client here wants to access resources in other storage device then there is no need of going through servers you see earlier it is always it will be going through the server but here there is no need of server so here actually here the storage devices are connected through a high-speed network. You see, high-speed network is here. And no server sits between the storage devices. And the network is used for interconnections. Right. So that is the difference between the storage area networks, SAN, and the backend networks. Next you see okay other applications the high-speed optics networks also LAN is used backbone also it is used in LANs are used in these applications right also it can in case of factory also factory local networks are there there are different applications of LANs are there. Now see the LAN architectures. In fact, the key elements of LAN, local area network, if you see, the key elements of LANs, the topology, transmission mediums, layout, wiring layout, and medium access controls. Right. The topologies you see here. Actually, it indicates topology indicates how end station, how the what end stations are attached to the network. Right. There can be topology can be bars, can be tree, bars, ring, star. There the different topologies are there. Right. Transmission medium also can be can be optical fiber, can be twisted pair, etc. That things are not things we have seen it. Layout, how the wiring layout is there, right? Whether it is the conventional layout like star type connections or something else. The wiring layout indicates the wiring layout, and the medium access control just will see it. So there are different topologies are there, and they will have different. I mean, they are having advantages and disadvantages. Say, for example, there are the different topologies. You see their characteristics here. How the bus here, the different stations are connected through a tap, through a common interface. This is the transmission mediums. Right. Transmission mediums. I mean here transmission from stations. Transmission can be in the both direction from stations. So particular stations, it can be in this direction, it can be this directions. So that is the bus. Tree is the more general forms of this bus. You can see the same way the different buses are interconnected, right? And this is the bus, right? Some problems are there. I mean, transmission from any stations can be received by all other stations. So some protocol is needed to whom the transmission is intended. Since you see from any stations, the information can go in both directions. So some protocol is needed, say to a particular if connection is needed to a particular stations from one station to another particular stations, right? And also some mechanism needed to regulate the transmissions. So there the different problems are there. In this case, can be solved by different protocols. Next, you see the ring. In case of ring networks, you see here systems are interconnected through the repeaters. Right here, data is in this case links are unidirectionals, and in particular directions data is circulated, and each stations attached to the networks through repeaters, and it can particular stations can transmit data onto the network through the repeaters. And in this case, data are transmitted in the form of frames, and it circulates, and it circulates, and the data circulates, and you see it will circulate till it is returned to the source point. Right, then it is removed. That is the star topology. Right. Here also some protocols are used here. Tokening protocols, some advanced protocols are there. If you read another advanced paper, specialized paper, the component networks, then these things will be discussed in details. Right. And in case of you see, in case of the star, in case of star connections, here each station is directly connected to the central hub. Each station is connected to the central hub, and there are two point-to-point links are there. One for transmissions, and other for the receptions. One for each directions. See here from stations to the central hub, and from central hub to a particular stations. Right. And here you see the problem is there. Heavy burden is there in the central hub, right? Because you see, all the transmission will be through the central hub, right? So the choice of so there are the different topologies, and choice of the topologies, it depends on several factors like reliability, expandability, performance, etc. Right? These things are there. There are the different advantages and disadvantages mentioned here. Ring topology. Medium access control determines, where you see medium access control is there, that determines when the station can insert frames. And data is circulated, that I mentioned, right? And when the particular frame returns to the source, then it is removed. In case of star, you see, just I mentioned, each station connected directly to the central node, and central node can broadcast like these things. So there are the factors based on these things. A particular topology is chosen. Ring, star, etc. Choice of mediums. Right, medium levels. Okay. Now see the protocol. So LAN protocol architectures. Right. So there I just have given some idea about the LANs. So LAN is basically a communication network where different systems or servers are interconnected within a small area, right? Within buildings or within offices, like these things, right? And there are key elements of LANs are there: topologies, transmission mediums, MAC, medium access controls. Other ones I just have sent. Three topologies, three factors are there that I mentioned. And the topology, transmission mediums, wiring layout. wiring layout and medium access controls. So now with these basic things, now let us quickly see what is the LAN protocol architecture, LAN protocols. Here you see LAN protocols generally constant in the lower layer of the OSI layers. Is in lower layers of OSI. You can see it here. Here, this is an example of IEEE 802 reference model LAN protocol architectures. That is the LAN protocol architectures. IEEE 802 reference models. That is for LAN architecture. This is the LAN architectures, standard LAN protocol architectures. You see it here. Here, lower layer is similar to this the OSI physical layers. So functions similar to the OSI layers, physical layers. So encoding, decoding of signals. It is here encoding preamble generations and removals for synchronizations. Right. Of course, here one thing is most important. In addition to those things, this physical layer of these 802 models, it includes the specification of the transmission mediums. You see, specification of transmission medium and also the topology. These are also included in this case LAN protocol architectures of physical layer of LAN protocol architectures. But the choice of transmission and the topology, it is very critical in LAN. So specification of medium is generally required, right? And the physical layers, you see, physical layers, the functions. What are the functions? The functions in the physical layers. Here this is assembled. Okay. What are the functions of the physical layer? On transmissions, it needs to assemble data into a frames with address and error detections. On receptions, it requires to disassemble the frames and perform address recognitions and error detections, right? And provide interface to higher layers and perform flow and error controls. Actually, they are the functions that are being provided in the upper layer of physical layers. Okay, that is actually MAC layer. Just to see, this is the physical layer. Physical layer simply these encoding, decoding, preambles, generation and removals, and the bit transmission receptions, and also it includes other things, the specifics of transmission mediums and the topology. Right, above the physical layers, what are the functions to be provided? Here it is. You see it here. Here, this one. These are the functions to be provided above physical layers. Assemble data into frames with address error detection fields. Disassemble of the frames with disassemble of frames. And with address recognitions and error detections, and it needs to govern access to transmission mediums. That is, this function is not found in data link layer. Data link layer, we have seen the simple flow control, error control, those things are there. But this access to transmission medium, it is absent in OSI, but it is present in LAN protocols. That is the most important things, right? And also it provides access interface to higher layers. Provide interface to higher layers. Let me mention here. Provide interface to higher layers and perform flow control error controls to higher layers, right? And if you see this, if you consider these functions, then the first three functions, actually the three functions, they are grouped together, right? And these are the functions performed in a mediums in a particular layer, that is the MAC layer, medium access controls. The first three functions, this one, and this one. These three functions are actually provided in a particular layer, which is called the MAC layer, medium access control layers, right? And the last ones that provides, just I mentioned, that provides interface to higher layers and perform flow control layer controls. That is being done in a that is being done in the LLC layer, logical link control layer. Right, that is the logical link control layer. You see now, you see it here. So here you see these ones. This is a medium access control. So here actually it is in case of 802 models. You see this layer is divided into two layers above physical layers. One is medium access control layer, and that is logical link control layers. In the medium access control layers, what are the functions provided? Assembling of data, disassembling of data, and access to the LAN transmission mediums. And LLC layer, it provides interface to the higher layers and perform flow control. So there are two sub layers are there in this above the physical layers. So the next time we'll see the different services also provided. Okay. Any questions from your side? I'm just stopping it here. Any questions till now? What I have discussed? Any questions from your side? कोई किसी क्वेश्चन तो पूछो. कोई किसी क्वेश्चन है कुछ? विशाल?
No, sir.
Okay, then next time we'll see it.